Hello and welcome to my presentation on EGPRS systems. My name is Ali Sayed Alian and I'm a student who's taking the lecture Introduction to Computer Networking, and this is my presentation, and I hope you will enjoy it and we will learn something out of this presentation. So, what is EGPRS? First of all, EGPRS system is a technology used in GSM mobile networks, and the abbreviation for is actually what is called Enhanced General Packet Radio Service, or just the evolution of GPRS technology. It is also known as Edge, which which is enhanced data rates for GSM evolution. It's it's not something we see on our mobile phones nowadays, but it's somewhat an intermediate term between 2G and 3G. It is somewhat what we call a bridge between 2G and 3G. Maybe some people have probably seen it when they use cellular network in that area. Now we have 4G and 5G in our era. We don't really see that term on our cellular networks when we are using our mobile phones. We usually see it. Maybe probably the least we could see is 3G. Nowadays, you won't see Edge written on your phone, on your mobile network. So it uses a package to switch data transmission, which breaks data into packets and send them independently on a network, and it's backward compatible with existing GSM and GPRS network. And the key features of the EGPR system is high data rate, which is around 400 plus kilobytes per second compared to a normal GPR system, which provides 110 kilobytes per second. Obviously, we don't really match those numbers from nowadays because it has been reached up to megabytes per second. Kilobytes are something very small numbers for the current era, but huge step towards the 4G and 5G era that we have right now. Uh, as for the quality, it can very well prioritize different types of data traffic more effectively with EGPR's high-speed real-time services like video calling, mobile gaming was introduced. As for the spectral efficiency, it used advanced modulation techniques like 8PSK, which is more efficient use of available radio spectrum. The comparison between the enhanced GPR system versus the normal GPR system, as we can see, this is a technical comparison of the both technologies. We can see significant changes in bit rates, while Edge also utilizing 8PSK for its modularization. As for the GPRS, it used just the GMSK system. Uh, just because of that, we can see there is a huge high rate, a huge jump in the modulation bit rate, and from there we come to the architecture component and architecture framework of the EGPR system. It is built upon these three components that we see right now on the screen. It's radio access network, which is a base station for communication, and base transceiver station, which is being the radio transceiver for the RAN, and lastly the base station controller, which is which manages the base transceiver station. So they're all uh, connected, and which brings us to modulation and coding for. And we talked about this before when we were comparing GPRS and EGPRS. So as we know that EGPRS uses both GMSK and 8PSK. G- GMSK is usually used for more robust but lower data rates, and 8PSK is used for higher data rates but more susceptible to interference. So EGPRS introduced adaptive modulation and coding based on channel conditions, and it also introduced link adaptation for optimal performance, and that's why we can see the modulation bit rates being much higher than what it usually is. As for the performance with EGPRS, these are some stats of performance that I'm going to share with you. Right now, it's EGPRS, a bandwidth of up to 236 kilobits per second with an end-to-end latency of less than 150 milliseconds for 4 time slots, with a theoretical maximum of 473.6 kilobytes per second for 8 time slots and packets modes. So what does it mean? It actually means that the latency has decreased, the data rates has seemingly increased, and also the 8 time slot also means that there are multi-slot classes in packet modes when we are sending packets uh, through the data. And lastly, the application and uses, as as I previously mentioned, EGPRS was a huge technology that was a huge bridge between 2G and 3G. It with it, a lot of applications and uses were introduced, mainly being web browsing and email, and multimedia messaging, and basic video streaming, and location-based services like GPS, and mobile gaming was introduced with it. Wi-Fi, cellular network mobile gaming, usually using online and multiplayer things, and also mobile banking and commerce was introduced as well, uh, which was a huge step for e-commerce as well, and social media also, and emergency services like SOS, and uh, a lot of a lot of things with that as well. And this brings us to the pros and cons and the limitations of the EGPRS system. As I talked there, after that 4G and 5G and LTE and uh, all of those cellular networks came up with, so they obviously the EGPRS always obviously had some limitations and some shortcomings. The pros being of that era that there was a huge reduced latency, and real-time analytics could be measured, and there was improved security considering the 2G networks, and also it was cost effective, and the connectivity was much more reliable than previously used technology like GPRS. As for the cons, the biggest reason would be the lack of physical security and the security concerns with it that comes up with it. Usually, if you are interested in cybersecurity, you would know that EGPRS was a very vulnerable network, and limited data storage capacity. So that was also a huge concern, and the network outages was very common. So yeah, they had some shortcomings. That's why 3G, 4G, and 5G was introduced, because they needed something which was much more faster, m- much better for security purposes, and who can have a lot of data storage capacity. And last but not the least, we come up to the conclusion. So what we have learned so far. We learned that EGPRS served as a huge improvement over GPRS and acted as a bridge for 2G and 3G. It was cost effective due to its compatibility with the existing GSM and infrastructure, which means that it was like backward compatible. And it was obviously a groundbreaking technology to set up the roots for further development, like 5G and LTE. And it is still valuable in developing markets like and IoT applications as well. So yeah, it's still valuable. It was a huge um, step forward to what how speedy and how fast cellular networks that we have right now. So that's it from my side, and I hope you will like my presentation.